Hello, I'm Andrea, Kilo 2 Echo Zulu, K2EZ from Sparta, New Jersey. And this is my VHF Rover. Also, it serves as my radio go kit for emergency operations. And on here I've got capability from 80 meters on up through 23 centimeters. Starting at the low frequencies, I have a Tar Heel Model 100, which gives me 80 meters through 10 meters. I run upwards of 400 watts on that band. And this antenna being mounted high is quite efficient. At the very top of the antenna there, I have the mast bent. I took a torch to that to keep the height down to something reasonable. When fully extended, the top of the the coil on the Tar Heel is at about 11.5 feet, excuse me. And so that would leave the whip up almost at 18 feet, which would hit way too much stuff. So by taking a torch to that, I tie it back to the mast at the rear of the vehicle, and that keeps the maximum height to about 12.5 feet. So moving to the back mast here, this tops out at 11.5 feet. This is VHF and UHF horizontally polarized antennas. At the very top, I have a 6-meter horizontal loop, which is my 6-meter omnidirectional antenna. It's a horizontal versus the typical VHF whips are vertical because I use it on weak signal, single sideband, CW, and digital modes such as FT8 and MSK144 meteor scatter. On the front, to the front of the mast, that's a pair of stacked 2-meter loops. And again, just like that vertical whip, it's horizontal polarized for weak signal work. And I stack 2 antennas to get a little bit of gain. Same deal on the rear trailing edge of the mast. I have stacked 1.25 meter loops. And then on the crossbar, I have 2 loops that are standing up. Those loops are actually the same 2-meter loops that I have horizontal. However, I use them on the 3rd harmonic for 70 centimeters. Well, the 3rd harmonic for 2 meters, which is 70 centimeters. Running those at 70 centimeters, they become directional, and the loop on the very back, the directionality is perpendicular to the loop, so that gives me a front-rear pattern, which is 120 degrees wide. It's the 3 dB down points approximately, and the one in the front gives me a broadside pattern. I have a switch inside the car, which lets me switch between the 2 patterns. From one to another, I can see 6 S-unit chain worth of change between the 2 antennas when I'm working a station. On the front of the vehicle now, I've recently added a set of Yagis and a rotator. At the very top, I have a 2-meter Yagi, 5 elements, I think it's about 12 dB gain. Just below that, I have a 1.25 meter Yagi, and then a 70 centimeter Yagi. These Yagis are special, well, Directive Systems makes a 8-foot Rover Yagi, but I wanted to keep everything within the profile of the vehicle, so these could, in theory, be used on the road, even perpendicular to the direction of travel and rotated mobile. So these are trimmed down to 6 feet, and roughly 6 feet, and the mounting points were adjusted to be as close to center as practical on the antenna rather than the balance point on the antenna. This means that there's roughly equal wind loading, and below these Yagis I have a 33 centimeter Yagi for 902 megahertz and a 23 centimeter Yagi for 1296. The microwaves are fairly new for me, and they've only seen use in one of the sprints so far this year. and it looks to remain to be seen what happens with those. Again, with these, they're optimized with the mount close to center. I actually had to modify one of those to get that center mounting. The rotator on there is a Yaesu, fairly heavy duty. It's a medium duty rotator. It's a lot heavier than what's needed for TV antenna equipment, and that was so it can handle the wind loading. There's a thrust bearing up on the mast just below the Yagis, which help transfer the load and get the lever force off the rotator and bring that back to the roof rack of the vehicle. The rough design goal is to be able to support 125 mph sustained winds without any issues on any of the antennas. That is considering like going out in Wyoming where I've been, where the speed limit's 80 miles an hour and then a 45-mile-an-hour headwind. Gusts getting up to that is easily seen, so everything's been made very rugged. Feed lines are mostly LMR 400. I've got some Belden 9913 up feeding one of the Yagis up here, and those both have about the same amount of loss. I tend to like the 9913 for the rotating antennas because some of the LMR 400 is, I've heard some complaints about it cracking. Inside the vehicle here, I've got and right now I'm changing how in the process of an upgrade, so it's kind of confusing, but I've been using up to date an Yaesu FT450 for my HF and my 6-meter operation. I have a Morse code key which is from my grandfather, and I believe that key dates back to around 1930 vintage. Then over on the passenger side, I have a Yaesu FT736R, which is my primary 2-meter and my primary 1¼ meter radio for weak signal, sideband and CW with that rig only. I also do 2-meter FM with that. I have a switch that lets me route it to one of the, and I forgot to mention that there's a vertical dipole on that rear mast, and the vertical dipole gets it a little bit higher up and works a little bit better than a 5/8 wave on the roof. The back of the car here, I've got, very difficult to see now, but under the blankets I have my VHF amplifiers. Far one, 90 watts on 70 centimeters, 100 watts on 1¼ meters, and an old, very old, 30-year-old 180 watt amplifier for 2 meters. On the floor I have a 500 watt HF amplifier, and I have in the old kitty litter container I have another car battery. There's a 4-gauge wires running from that car battery to the main car battery. I'm using a stock alternator, which is 130 amp alternator, possibly 160, but 130 amp is sufficient. The biggest load current is the 500 watt amplifier, which draws upwards of 80 amps. The exciter, when I'm running that, is only running at 25 watts. So that power is about 10 amps. Most of those are peaks on sideband, come from the local battery inside the vehicle here. On top of this is the new hardware I'm adding in these blankets, which are no good because they insulate the heat sinks on the amplifiers. I have in the back a 900 megahertz, which is a 902 megahertz, 33 centimeter transverter assembly with TR switching. So that was part of the new hardware. And a little bit just forward to that, there's some other TR switching with a small amp that adjusts the 5 milliwatt output level of the Flex radio I've got here, the Flex 6700. for 2 meters, and that little 2 watt amp out is used for 5.7 and a 10 gigahertz transverters that I have. I don't have that antenna on the car, and I haven't. That's part of the upgrades. Don't know if it'll mount on the car or whether I'll deploy from within the vehicle. The Flex radio is the new, coming in for the new system. It will replace the Yaesu largely, 6 meters, and HF. I keep the one in until I get everything worked out on the other. The Flex also will drive the transverters. The 6700 has a 2 meter, 5 milliwatt capability, so I can use the 2 meters as an IF, and that works very well with 902 megahertz transverter.
You're violating my First Amendment right.
I forgot to mention on the FT736, I also have 1.2 gigahertz. That receiver's not so good, so I'll be getting a 1.2 gigahertz transverter in the not too distant future to replace that. I've got about 10 watts out on 902 megahertz with this assembly here. I have a 40 watt amp, but just not enough drive to get the full output on that. So that's kind of a quick rundown. There's some switches, and the coaxes are hooked up to different things at the moment. Most of it's available, but I've kind of compromised with some of the switching at the moment. So I don't have all antennas on at one time. I got to move a coax occasionally. As the upgrades continue and I get mounting, I need to make some hardware, like obviously I'm not going to use Flex radio or driving. I can't work through the computer control. So I'm making some discrete controls. I also have a regular control knob, which lets me use it no different than the Yaesu FT450 for dialing frequency. I have a small power inverter for 110 volts, which handles the rotator controller. But I also have a green heron rotator controller that runs on DC. The rotator motor itself is DC, and so I'll be able to get rid of the AC for that and just use the AC for some incidentals like the wireless LAN. Handy thing about the wireless LAN is it lets me, one of the design goals here is to be able to just take that out and go bring the laptop to a control center, a command post for like emergency operation, or if I just want to get outside the car, I just have to take that laptop and I can operate everything through the Flex, and that will give me all the HF and VHF operation that I need. And it gives me a roll onto site capability, grab the laptop, go into a command post, and operate emergency operation from in there.